In my last video I demoed starting development of a bomber game for the ZX81 using the C programming language. Back in the day the only options for development on the ZX81 was ZX81 Basic and Z80 Assembler. So having C as a possible development language opens new doors. ZX81 Basic was too slow for many games, and Assembler took too long to write. I showed creating a library of C functions which would do the screen handling, randomization and input, and then using these to write the start of the bomber game. Bomber though only has a small amount of screen activity going on, with the plane moving across the screen, the bomb dropping and the city blocks being destroyed. So my concern was that while C might be okay for a game like Bomber, that it wouldn't be fast enough for a more screen intensive game. So in this video I'm going to attempt to use Copilot to optimize these library functions to Assembler, so these slower screen operations could be run in machine code directly, while the more complex game logic could still be written in C, the game logic being the thing that would take the most time to write in Assembler. So I set about converting the library to machine code. These are the functions that I wanted in the library. I thought I'd try Copilot on the library conversion from C to Assembler. I started with the print-at routine. The last time I tried to get AI to write Assembler, it failed miserably, not producing anything useful at all. And this time, while it did seem to come close at one point, it couldn't produce working Assembler embedded in C for the ZX81 for the function even after a good number of attempts. It was talking the talk but walking a crooked walk. So then I tried OpenAI, then Claude. Neither could do it, and this was only a small C function. Claude's code was the most succinct and readable, but still didn't work. I asked Copilot why AI was so bad at Z80. It said there wasn't enough source material for it, and a lot of the source it had was very hacky and badly programmed. So I ended up manually coding the print-at in Assembler, then the getChar. Figuring out how to get the parameters out of the C into the assembler took a bit of time. Then returning a value also took some time with getChar. You use SP instructions to read the parameters off the stack and pass a value back from the assembler using the HL register pair. I tried running performance comparisons of the full C version of my test program with the new print-at and getChar against the C with the embedded assembler in the library. There wasn't much difference in speed. So either the Z88DK C compiler is very efficient, or I'm very bad at Assembler. But that was just printing and getting one char. Next I tried the invert area routine in Assembler, and hoped this would improve the speed of flashing an area of the screen, which I'd used in my bomber splash screen. So inverting an area by reading through it character by character in C, inverting it and then writing it back to the screen, using my getChar and print-at was slow. Not fast enough for what I wanted. So I wrote an invert routine in Assembler, and this was much faster. Copilot assisted me, and this time it was working better. Now the Bomber text was flashing much faster, more like the TypeScript version of Bomber. Certainly acceptable. Next I wrote a fill screen routine, passing in the character to fill the screen with, which had a C signature, but then ran some embedded assembler. This was really fast and much better than using the print-at function in a loop for each character. I thought to test this out further I would develop a small demo which showed more and larger animated sprites being displayed on the screen. The game that sprang to mind for multiple large sprites was Mazogs. So I set about developing the intro screen for Mazogs using C with embedded assembler. I defined the Mazogs sprite in a library file called Mazogs.data.h. Then ran the print-at with the embedded assembler in loops for each character to display the large Mazog sprites in C. Some of the sprites animate, such as the Mazogs moving their legs, the treasure, and the prisoner's eyes flash on and off. This updated fast enough for the splash screen, and I think it would be fine for a game. So I think C with some embedded assembler for screen intensive operations will be fast enough to write a more display heavy game. My next step is to write a C routine with embedded assembler where I can pass in the whole sprite and its position on the screen, and it prints the sprite in assembler without needing to have loops in C to call the print-at function for each character as I've done here. So that's writing C programs for the ZX81 with embedded assembler for screen hungry operations with the main game logic written in C. I think its speed is fine. Very likely the P file from the C code will be larger than an all-assembler P file, so it may not be possible to squeeze as much functionality into the ZX81 16K of RAM for a game when using C. The size of bomber.p so far is 7K, and Mazogs.p is 4K, so some space for the rest of the games in 16K. You probably wouldn't be able to finish Mazogs using C like this. Bomber, maybe. And will I continue with this method and maybe write some games with it? Well, writing Z80 library routines and plugging them together with C is a lot easier than writing your entire game in Z80. So maybe. If you want to look at what's in the Z88DK ZX81.h library specific to the ZX81, I'll leave a link below. So I hope that was interesting, and thanks for watching.